Okay, now we look at example 4 in page 50 from chapter 2 in your handout. Okay, this is from previous semester papers, April 2007. Find dy dx if xy equals to inverse sinh tan x over 2. Okay. Okay, first step, let we define one by one. Let we define A equals to xy and B equals to inverse sinh tangent x over 2. Okay, then we differentiate one by one. Okay. Okay, to differentiate A, we can use product rule because this is multiplication operation between two variables. Okay. Okay, when we use product rule, we need to identify which function as u and which function as v. So now our u is x. Okay, then we need to find u prime. Okay, u prime is 1. Okay, and then our v is y, and when we differentiate, we have dy over dx. Okay, the symbol for v when we differentiate is v prime. We differentiate y, then we have dy over dx. Yeah, we differentiate with respect to x. Okay. And after that, we can write product rule formula. A prime equals to, when we differentiate A, so the symbol become A prime. And then when we use product rule, the formula is vu prime plus uv prime. Okay. And then we substitute, okay, in this formula. So we have A prime equals to v times u prime means y times 1, which is equals to y, plus, okay, u times v prime, so x times dy dx. So we get here. Okay. Okay, and then let me look for b. Okay, our b is inverse sinh tangent x over 2. Okay. This is composite function, means that x over 2 inside tangent and tangent x over 2 inside inverse sinh. Okay, this is not product rule. This is not multiplication function. Okay. Okay, so we need to differentiate using composite function rule. Okay, first step, when we differentiate b, so the symbol become b prime. Okay, and then we differentiate inverse sinh, we have this. Okay, I will discuss later about this. Okay, and then times z squared x over 2 and then times half. How we get this? Okay. Okay, if we want to differentiate inverse sinh tangent x over 2, okay, we can refer from formula inverse sinh x. Okay, we just assume inside inverse sinh is x. So from formula, okay, derivative of inverse sinh x equals to 1 over 1 plus x squared square root. Okay, now our x is tangent x over 2 here. Okay, so what need we do is we just copy 1 over square root 1 plus here, we copy, okay, from this formula, and then we replace x by tangent x over 2 here. Okay, 1 over here, 1 over, and then square root, and then 1 plus. So x now we replace by tangent x over 2 because we need to differentiate function inverse sinh. Okay. And after that, we differentiate tangent x over 2. Okay. So how to differentiate tangent x over 2? We refer from derivative of tangent single x. Okay. So from formula, derivative of tangent x equals to z squared x. So if we want to differentiate tangent x over 2, it should be z squared x over 2. Okay. And after that, we need to differentiate x over 2. Okay. How to differentiate x over 2? we can rewrite x over 2 by half x. Okay, when we differentiate 3x, it becomes 3. So when we differentiate half x, it becomes half. Okay, so we can put here. Okay, is it clear? Alright, and then we can simplify using trigonometric function. Okay, trigonometry identity here. Okay, how we get this? Okay, from trigo identity, we have 1 plus tangent squared 8 equals to sec squared 8. Okay, now our A is x over 2. Okay, here. So if we have 1 plus tangent x squared, x over 2 squared, okay, we can write sec squared. Our A now is x over 2. Here. Okay. Okay, and then after that, we can simplify square root and square inside square root here. Okay. So after we simplify, we have no more square root symbol and no more square. Okay, inside square root. So we just have 1 over sec x over 2 sec squared x over 2 times half. Okay. And after that, we can simplify sec squared and sec because we have same angle here. Okay, x over 2. So we can simplify sec squared and sec. Okay. So after we simplify, we have half and then sec x over 2. Okay, no more denominator sec x over 2 because we simplify with sec squared. Okay, got it? Okay, after that, we refer from the given question. Okay, we have x, y equals to inverse sinh tangent x over 2. And we want to find dy dx from here. Okay. Okay, now we need to differentiate implicitly with respect to x. But in previous slide, okay, we differentiate left hand side and right hand side one by one. Okay. We differentiate xy equals to y plus x dy over dx. Okay. And from the previous slide, we differentiate inverse sinh tangent x over 2 and the answer is half sec x over 2. Okay. Okay, now we have denominator 2 here. So to eliminate denominator 2, we can multiplying each term by 2. Okay. The blue color is from above. And the red color is when we multiply each term by 2. Okay. So after we multiply by 2, we can simplify 2 in denominator and 2 here. So after we simplify, we have 2y plus 2x dy dx equals to sec x over 2. No more denominator. Okay, no more half and 2 here. Okay. And after that, we need to separate the term containing dy over dx and the term not containing dy over dx. Okay. In this case, I bring the term not containing x to right hand side. Okay. Okay, now we have 2x dy over dx. Okay, term containing dy over dx. And then right hand side we have sec x over 2 minus 2y. Okay, this is term not containing dy over dx. Okay, after that, we can write dy over dx as a subject because we want to find dy over dx. So we need to move to x to right hand side. So when we move to x to right hand side, it becomes sec x over 2 minus 2y over 2x because 2x is multiplication operation. So when we move to right hand side, it becomes division operation. Okay. So the final answer is dy over dx equals to sec x over 2 minus 2y over 2x. Okay. Is it clear? Okay, coming up next, still under inverse hyperbolic function, derivative of inverse hyperbolic function from previous semester papers. Okay, so stay tuned. Bye. Assalamualaikum.